Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about language model evaluation. This episode is based on a tech blog titled Evaluating RAG Capabilities of Small Language Models, written by the data science team at Microsoft. You can find the link in this episode's description. Throughout this episode, we will explore this topic from both the business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Over the past few years, large language models have transformed how businesses operate. They now power customer support chatbots, document search systems, creative writing tools, and even software development assistance. Their strength lies in generating trust, context-aware responses across a wide range of topics. But to make large language models practical for real-world products, two concepts stand out. The first one is called RAG, or retrieval-augmented generation. This technique allows the model to pull in external documents, like a knowledge base or real-time data, and then use them when answering user questions. Without this retrieval approach, a model can only rely on what it memorized during the training time, which quickly becomes outdated or incomplete. The second concept is the long context window, essentially how much text a model can process in a single query. A longer context window enables the system to consider more documents or user history, which is crucial for analyzing long reports or searching across large collections of data. Together, the retrieval and the long context window are central to building trustworthy AI assistants. Another piece of the puzzle is small language model. Unlike massive models with hundreds of billions of parameters, small language models are much lighter. They are cheaper to run, faster to respond, and easier to deploy on edge devices or across millions of users. For businesses, this efficiency can be a game changer. But there is a catch. Smaller doesn't always mean better performance. The big question here is whether these linear models can still handle demanding tasks like retrieval and long context reasoning effectively. That brings us to the core challenge. How do we know if a model, especially a smaller and cheaper one, can reliably use retrieval and a long context window? For businesses, fluency alone isn't enough. A model must consistently surface the right information from a sea of irrelevant details. That's where evaluation comes in. Marrying these capabilities helps companies decide whether a smaller model is sufficient for deployment, or whether they need to invest in much larger, more expensive models. And within this evaluation, the retrieval capability is particularly critical because it directly affects user trust. Imagine asking a company chatbot about your billing history. If the model can't locate the correct detail from your documents, the answer may be wrong or misleading, no matter how polished it sounds. Now that we've understood the business problem to solve, let's dive into the technical side to see what solutions might work. This tech blog focused on a method called Needle-in-a-Haystack to evaluate retrieval performance in language models. The idea is simple but powerful. You take a long piece of text, which is a haystack, and then you insert a small but critical piece of information, which is a needle, somewhere inside this haystack. Finally, you ask the model a question that can only be answered if it successfully finds the needle. If the model can locate the needle and answer correctly, it shows that the model is capable of retrieval in a long context scenario. For example, imagine the needle here is the sentence, "The best thing to do in San Francisco is sit in Dolores Park." The haystack could be a long file like Microsoft quarterly earning report. The test question here could then be, what is the best thing to do in San Francisco? A strong performance model on retrieval should ignore all the irrelevant financial data and surface the right detail. To make this test more comprehensive, the researchers varied two key factors. The first was context length, which is how much total text the model needs to process. They tested shorter versus longer contexts to see whether performance declines as input grows. The second factor was document depth, which is where the needle is placed. Sometimes the needle is placed right at the beginning of the documentation. Sometimes it's buried in the middle, and other times all the way at the end. This design helps measure whether models suffer from the lost in the middle problem, where important details get overlooked if they aren't at the edge of the input. With this setup, once the model generates an answer, the evaluation doesn't stop at a simple string match. Instead, the team suggests using GPT-4 as a grading assistant. GPT-4 compares the model's output against the ground truth and assigns a score from 1 to 10. A score of 1 means the answer is completely unrelated, while a score of 10 means the answer is fully accurate and perfectly aligns with the reference. This grading approach is more flexible than those rigid keyword matching because it can recognize paraphrases or partially correct answers, making the evaluation both fair and more informative. So what does the results look like? Base small models, which is the ones without fine-tuning or alignment, struggled with this task. They often fail to retrieve the needle, especially when it was buried in the middle of long documents. Although some models stood out better than the others, overall, untuned models had clear limitations. Fine-tuned or instruction-aligned models, on the other hand, performed much better. Models like Llama 2 7B, where instruction-tuned, can demonstrate strong retrieval capability. The results made one thing clear: alignment techniques significantly boost the retrieval performance. And interestingly, model size here wasn't the only driver of success. In some cases, smaller aligned models can outperform some larger ones. This shows that fine-tuning strategies and data quality can matter just as much as raw parameter counts. While this tech blog centers on the needle-in-a-haystack methodology, which is simple and intuitive, it also points to some more advanced benchmarking efforts. One of the most notable ones is NVIDIA's Ruler benchmark, which is short for Realistic and Universal Language Model Evaluation with Long Contexts. Unlike the single needle setup, Ruler tests a wider range of long context skills, including multi-hop reasoning, summarization, and question answering across massive text sets. For practitioners and researchers exploring long context capabilities, Ruler represents a promising next step. Now that we've discussed both the business problem and the technical solution, let's wrap it up. In this episode, we explored how to evaluate the retrieval-augmented generation capabilities of small language models. On the business side, we saw why concepts like RAG, long context windows, and small language models are all critical for building scalable and reliable AI systems. On the technical side, we walked through the needle-in-a-haystack methodology and discussed some of the key findings about retrieval performance across different models. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.